Japanese Canadian Cultural Centre. Location, Toronto, Ontario. Size, 51,000 square feet. Completion, 2004. Site location, 6 Gerwin Court, Don Mills, Ontario. The Japanese Canadian Cultural Centre, also known as the JCCC, is a contemporary institution that integrates cultural programming and economic development. Simplicity, economy, and quality were the guiding principles in the design of the new center. A combination of new construction and strategic renovation transformed previous office building into a cultural facility that is welcoming, accessible, and inclusive. The design embodies an idea of community and provides a flexible infrastructure for the full range of programming offered by the institution. The structure of the building is structural steel framing with steel decking and poured-in-place concrete. Since the auditorium is used for dancing performances, a raised floor has been constructed with an underfloor heating system. The main interior materials are wood, glass, concrete, and stone. The main exterior materials are concrete and steel and glass. The entrance area is wrapped in large steel and cedar screens that draw attention and resemble Japanese style. The Japanese Canadian Cultural Centre has a rooftop unit system. This is the LGC 300S-1J model and is located on the balcony. There are 2 main ducts that run lengthwise of the building and 5 shorter ducts that run widthwise, connecting the 2 main ducts together. There are 50 linear diffusers, 10 on each short duct. Each short duct holds a single baffle in order to distribute air equally in both directions. The electrical systems within the JCCC are integrated into the ceiling, floor, and surrounding walls. The location of the lights are placed according to the architectural drawings, but may be relocated according to the current building site. A majority of lights are fluorescent, either recessed or pendant-mounted fixtures. The lights used in the area with high ceilings require 250 watt, while smaller rooms require 32 watt to operate. The luminaries that are installed in the suspended ceilings are supplied with safety chains securely attached to their main housing and supported from the building structure. All the lighting throughout the space is fed from a 20-1P breaker unit. Additional breakers and circuits were provided for extra electrical power and are placed where the existing panels are located. Plumbing for the Japanese Canadian Cultural Centre include hot and cold water supply, sanitary drainage and cleanouts, vent pipes, stormwater drainage, a fraction collector, condensate drains, and roof drains. The plumbing for the building connected to existing plumbing located outside of the building. The systems that were being used to heat the water in the external location were not indicated on the plans. The plans also did not indicate hot water supplies. We included them, no closer than 6 inches to the cold water supply to avoid heating or cooling effects due to transference. An outdoor sink in the courtyard required a hot and cold water supply and sanitary pipes, which were run underground, just above the footing of the building to avoid freezing. The half-inch copper pipe were run within a 3-inch PVC pipe to further protect them. Within the structure of the building, the water supply and sanitary pipes were run within the flooring of the structure as there were limited walls within which to conceal the piping. Cleanouts were inserted throughout the sanitary system wherever pipes were meeting and joining. Vent pipes were added to the waste piping a short distance downstream from each tap to prevent the pressure that would allow dirty water and sewer gases to get through the taps. These pipes run upward and eventually poke through the roof. The fraction collector used to prevent condensation from forming on important components, i.e. air conditioning units, gather water and sends it to the condensate drain. Roof drains collect water into stormwater pipes that run on the roof of the building and then run down through the building and into the buried stormwater pipes. As interior designers, our prime concern is the health and safety of the occupants, since this entails all the aspects that can jeopardize human life. Within an enclosed interior space, the major threat is fire, and there are various of ways to prevent this. Fire barriers are fire-rated structural elements which include walls, ceilings, or floor systems. In the JCCC building, there are 4 main spatial areas: the front entrance area, corridor, main hall, and the mezzanine. These are separated from one another with 1-hour fire-rated walls, with the exception of the corridor adjacent to the main hall, which has a 2-hour fire rating. These fire-rated walls prevent fire, smoke, and heat from spreading throughout the entire building, or at least substantially delay it. The stairway has a 2-hour fire rating that allows the occupants sufficient time to evacuate the building in the event of a fire. There are also areas of refuge that are located adjacent to the stairway, which are equipped with a communication device to contact a rescue team. Vertical openings such as stairs, elevators, plumbing chases, ductwork, and electrical wiring are all enclosed in the fire-rated walls and self-closing fire-rated doors. Egresses are calculated according to the occupant load of the building and are placed no more than 40 feet apart from one another. The connection to the next building is to be considered as a horizontal exit. This is a type of exit that does not lead to the exterior of the building, but it does take the occupants to a safe area of refuge. All the exit signs are carefully placed so they are visible from all directions in order for patrons to locate them as early as possible. Emergency lights, fire extinguishers, smoke detectors, fire hose cabinets, fire bells, and annunciators are placed throughout the building in appropriate spacing to maximize the safety and well-being of the occupants and to minimize the impact of an emergency. During the site visit to the Japanese Canadian Cultural Center, it was found that there were some changes in the as-built structure in comparison to the architectural drawings we worked with. Upon arrival, we noticed that the exterior wet bar that appeared on the plans was not installed at the site. Within the building, the mechanical, electrical, and fire and safety systems remained very similar to the plans, with the exception of additional theater lighting installed after the completion of the building. We also found that, as expected, there was additional fire and safety signage on the walls, such as a map indicating means of egress. Within the mechanical room, there were numerous pipes, more than expected in having read the plans prior to the visit. We believe the small red pipes supplied the in-floor radiant heating for the building. The electrical panels were accounted for in our drawings. Overall, the space was quite similar to what we expected in having read the plans, with shifts in locations of systems being relatively minor. This project taught us how to read detailed plans, and that what is drawn and what is built does not always directly correlate.